Dan silakan Pak Anton untuk beristirahat. Kita akan menginjak ke sesi kedua terkait dengan Activated Clay Teknologi yang diberi judul Polysius Activated Clay. Pada sesi ini akan disampaikan secara lebih rinci apa itu Activated Clay, bagaimana proses pembentukannya, dan akan ditunjukkan juga business case terkait clay yang ada di Indonesia. Okay, entering the second session related to the Polysius Activated Clay, Mr. Leo Fit will give his presentation. Little bit information about Mr. Leo Fit. He started his career at thyssenkrupp Industrial Solution AG in 2015. After his first position as a process engineer, he took over the innovation management and program management for the Gray to Green initiative. Today, he is responsible for the global product management of the thyssenkrupp activated clay solution. Mr. Leo, you have 40 minutes for the presentation and then 20 minutes for the answering the questions from the participants. Now it's time for you to give your presentation, Mr. Leo, and please.
Okay, so I hope you can hear me, everybody.
Yeah, I do.
Good. So, hello from my side. Good morning or good afternoon, I have to say, since here in Germany it's 8 o'clock in the morning now, 8:40. So it's a pleasure for me to show you, to give you some insights into our activated clay solution. So today I will focus on, let's say, our lab services on the one hand, as well as on the technological realization of the product. And at the end, I will also show you a business case, just a generic business case for Indonesia, which is also quite interesting for you, I would say. All right, but first of all, let's start now with my presentation. So I would like to start with this slide here, since I think that the drivers, to understand the drivers for activated clay, is the most important for our customers. So for sure, this technology is good, let's say, to save the environment, to reduce CO2 emissions. That's very clear for all of us. But there are some other drivers. And this is especially if you have some high clinker costs, or in general, if you would like to reduce your cement production cost, then this is a quite good alternative. If you would like to increase the cement capacity in your markets, this is also quite beneficial to go for activated clay solution. And for sure, the CO2 level, which we at the moment see, especially in Europe, but this will also come in some other regions of the world soon. So basically, these are the three main drivers we see in the market, and all is leading to the same, let's say, measure at the end. So this would be then the reduction of the clinker factor. So this is what we're talking here today about, the reduction of the clinker factor. So let me first of all give you an overview about our TKIS Polysius approach, how we are doing our projects with our customers. So basically, I have to say that the most important of all our collaborations with our customers is the business case evaluation on the left-hand side. So at the very beginning, we are starting to evaluate the markets of our customers, and we show the customer that this business case is positive. Or maybe if it's not positive, we will also say to the customer for sure. So this is one very important pillar of our strategy together with the customer. And this I will show you later. Additionally, what we are offering is a so-called Geoservice, meaning to support our customers in terms of taking the right samples in the regions, or let's say finding the right deposits. So this is basically where ISBI can support you. Then we're going over into our lab services, meaning we are taking the samples, bringing them to Germany in our lab, and we are testing it. So there are three main tests we are doing. So this is divided into three packages. The first package is a quite basic analysis, meaning we are having a look on the chemistry, for example, on the mineral composition. We are looking on the energy demand for activation, for example, but as well as to emissions. If we could show that this clay is a good one and this clay could be used in a real plant, then we are going over to the cement quality forecasting. So this is a quite important point because we would like to produce a cement quality which is according to your needs at the end. So it should not be too good, let's say, but it must be the right quality at the end to substitute the cement you have today in your portfolio. This is the target. And for this, we need to do a small scale activation in our lab. And we have to do some mortar testings, first of all. So we are taking some different compositions, for example, of clinker, limestone, gypsum, and activated clay for sure. And we are testing several compositions. And we are finding out the best composition for your market. This is what we're doing in the lab service package 2. Finally, if we could find the right cement quality with the available clay, then we are going over into the pilot scale flash activation. This is what you can see on the right-hand side. Our so-called Polycarl solution. This is a preheater calciner system. This is in Germany. And we are activating around 1 ton of material. We are also investigating the cooling parameters. We're having a look on the wear, and we are selecting the process accordingly. So after this test, we can say, okay, you have the right clay, you can formulate the right cement quality, and you can activate the clay within the flash device. So we have all the informations we need to really come to a technical feasibility and to find the right solution for you. This is our approach, and this is the most important to let you know about this procedure here. So then, if I go now into the Geoservices, I will take the laser pointer. So basically, this is something we did for a customer in Africa. So there were several deposits available, and we had to choose the right one at the end. So what we did is that we investigated together with the customer all the quarries which were available. We took samples together with the customer. We had an exploration program here to find the right and let's say clay quality and also quantity. That's also very important to have enough clay as a reserve. And basically, we also send out our geo experts in the region. So what I want to say here is that if you need some support, we can assist you, but also ISBI can for sure assist you in taking the right samples and in finding the right clay sources. This is absolutely no problem. So when taking the samples, we are sending them to our lab in Germany, and we are then going over into our lab services. So what you see here is our R&D center in Germany. It is in Beckum in the northwest of Germany. This is our just R&D center. The headquarters is somewhere there in this area. So what we have here is our lab in this building here. And we are having our Polycarl clay activation units within this building, as well as one outside the building. So this is the bigger one, and the smaller one is within this building here. So let's come to the needed clay quality. So this is divided into 3 steps here. This is physical parameters, this is chemical parameters, and mineral parameters. So when talking about physical parameters, I would like to point out 3 things here. So this is the first point. We are able to use sedimentary clays as well as weathered clays with impurities. So in this case, if you have some impurities, something like hard rocks, then you can simply, or we can simply apply machines to put out the hard rocks out of this material. Additionally, we can handle uneven clay deposits. So in some cases, a mixing bed is needed, but not in all cases. So there's also a certain mixing effect if you don't have any mixing bed or something like that. And the last point here from the physical parameters is the moisture content. So we are able to handle up to 35 or 40% of moisture with our equipment. For sure, this will have an impact on the heat consumption at the end. So this must be in line with the business case. But typically, we are more talking about moisture levels between 10, 15 to 25%. This is typical for clays. If we now come to the chemical parameters, then there is a certain demand on alumina oxide within the clay. There is a certain ratio which is needed between alumina as well as silicon, and the LOI should be above 7%. So this is just a very, very rough estimation. So if you just have the chemical data available of your quarry, for example, then you can check these figures. And if you are, let's say, near to such numbers or above, then you can say, okay, this might be a good quality for activated clay. But this is not enough. So if you could show that this is fulfilled, then we have to do some more detailed testings. And this is, as I said before, everything done in this lab service number 1. For example, we are having a look on the mineral composition of the clays. So having a look on the kaolinite content, or having a look on other clay minerals, for example. And this is what we're doing. So just to give you an overview, what is needed. For sure, this is depending on the clay, on the cement quality you would like to produce at the end. But typically we are saying a kaolin content between 20 and 40% should be sufficient, depending on the case for sure. If you would like to substitute an OPC with the so-called LC350 cement, then a kaolin content of around 40% would be needed. If you would like to produce some lower quality cements at the end, then you can also go with some lower kaolin contents. So what is very important to know for you is that not just the clay mineral kaolinite can be activated, but also some other clay minerals which are contained, something like elite, muscovite, etc. Also, this can be activated. At the end, it could be shown that kaolinite is the most important clay mineral with regards to strength development. Okay. Just to show you one example, here in this graph, you can see in total 8 samples. So this is one pair of sample here. This is one sample, second, third, etc. So in total, it's 8 samples. And what you can see here is the very first investigation when looking on the chemistry. This is what I just showed you on this slide before. So in this case, for example, for this kind of clay or for this quarry here, we see an LOI, which is around above 7%, which is good. So the LOI is okay. We see the ratio of alumina to silicon, which is only 0.1. So this is too low. This is not considered as a good one, as well as the alumina oxide content, which is here on the x-axis, is only around 11%. So this one here, this sample, will not have a good quality for activated clay production. This is for sure. So then the other extreme is a very good sample here, for example. So here we can see that the LOI, this is the red one, is around 14–15%, which is fitting, which is good. We see that the alumina to silicon ratio is quite high, which is also good. And we see that the total amount of alumina oxide is above 18%. So we are in the green region, which is giving us the indication, first of all, that this is a very good clay. So we have some good clays here, 2 samples. We have some quite bad ones here, and there are also someone in the middle. And here, especially, we have to have a detailed look on. So we cannot say that this is suitable or not suitable. We have to really do some mortar testings to find out. But today I would like to focus on the good clay samples first of all. And this we did an activation for. I will show you on the next slide. So what you see here on the left-hand side is the TK7 and TK8 samples. So this is the good samples, which I just showed you on the slide before. You can see the left bar, this dark blue bar, this is the elite content, which is quite low in both cases, so just around 3 to 5%. Then we see the kaolinite content. This is the middle bar here. This is around 30 to 55% kaolinite in the raw clay. We are talking about the raw clay here on the left-hand side. And then you see the so-called amorphous content in both samples, which is in both cases around 30%. So the target of activation here in this case for this customer was to fully activate the kaolinite content. And this is what I would like to show you now on the right-hand side. So here you can see the elite is nearly the same than before. So we did not activate the elite because this was not the target. We can do it, then we have to go to higher temperatures, but we did not because it was not the target in this case. But we wanted to activate the kaolinite, and this is what you see here. There is no kaolinite anymore in this sample of the activated clay. All the kaolinite is transferred into the active amorphous phase. This is what you see here. And this is the same for the sample TK8. So we are pretty well able to activate this kind of clay in our flash device. And we are able to transfer all the kaolinite into active phase. So this is a highly reactive activated clay, which you see here on the right-hand side. Okay, just to give you some indications on the quality of such a cement, please have a look, first of all, on the left-hand side. So what you see here is the compressive strength about the days, right? So this is the first day strength, 3-day strength, etc. We are comparing a standard OPC, which is the left gray bar in all cases. And this we are comparing to a so-called LC350 composition with around 40% kaolin in the raw clay. This is in brackets. This is meaning the kaolin content of the raw clay. So you have this composition, which means that there is 50% of clinker, 30% of activated clay, 15% of limestone, and 5% of gypsum. This is this one here, the green one. And then there is another one, which is the PPC30, also produced with 40% kaolinite content in the raw clay. And the results you can see here. So in general, what we see is that the performance of LC350 and PPC30 are more or less the same. Yeah? So the PPC is a bit better because the clinker content is higher, but in general, it's the same behavior, more or less. We see that, wait, it was me, sorry. Can I delete that? Oh, sorry, I have to. I will restart this presentation. 1 second, please. And then I will go ahead. So sorry for that. So what we see is that the strength of this activated clay cement is typically, especially when talking about the early strength development, it is lower compared to OPC. But it's in the same range compared to limestone cement. So especially after 7 days, you see that the strength of these cements is equal to OPC, but with a clinker of only 50% in this case. So it's a quite low clinker content, but a very good strength. And even after 28 or 90 days, the strength will exceed the OPC. So this is very good results. And this is the reason why activated clay is pushed so hard in all markets at the moment. Everybody is talking about this one because it's a quite cheap substitute, and it is also giving some strength advantages. So limestone is just a filler. Activated clay is also giving some strength contribution at the end. So when we're talking about, for example, limestone cement substitution, then we can even go very low with the clinker ratio. So this has to be investigated for all cases in the lab. But we can imagine that the clinker content can be lowered to 40%. This can happen depending on your clay, depending on the clinker, etc. So this has to be investigated. But then for sure you will come up with a quality which is equal to limestone cement quality at the end. Okay, so what I just mentioned is that we are also activating the clay in our facility in Germany. And this is the so-called service package 3 here. So this is our Polycarl flash activator, which is consisting of a preheater string. This is this one here, as well as an activator string, which is here. So basically, we did lots of investigations with this facility. We could activate most of the materials here, and we are also able to do the so-called color control, which is basically needed from most of our customers today. With this facility here, we are able to produce around 50 kilograms per hour. So this is not to produce lots of material, but it is to show the feasibility of the process. If we want to produce more activated clay, we are going to the second device, which is outside this building. And there we can produce around 500 kg per hour, which we also did for a European customer where we treated 20 tons of material and activated it. Okay, this is then now bringing me to the technical solution. So basically, first of all, I would like to bring to your attention what is happening when activating the clay. And this is what I want to show you here. So first of all, the clay must not be of a very, very high quality. This is not needed for activated clay production. So we don't need the high kaolinite content as you need it for ceramics production, for example. This would be far too expensive, and we don't need it for the cement quality. What we need is what I just told you before. So something with a kaolin content between 20 to 40% would be good, and a certain chemistry accordingly. So when activating clay, we are talking about, first of all, a water evaporation. And then we're talking about a dehydroxylation. This is what we're doing. And typical temperature ranges are then for the first step between 500 to 550 degrees C. And then the activation, meaning bringing the kaolinite to the metaphase, is done at a temperature between 750 and 950 degrees C. Also, this is then depending on the clay itself. So this we are evaluating in the lab before to find the perfect activation temperature for the best product quality. What is very important to know is that we don't want to overheat the metakaolinite. Because if you overheat it, for example, in some rotary kilns, this can happen, then you will form some other phases which are not active anymore. So you are destroying the activation and you will come up with a very low product quality. And this is not our target. Our target is to produce the best quality activated clay out of your available raw clay. This is our target. All right, then let me just go ahead here. So in this case, let me tell you our strategy here from TKIS Polysius. So for sure, first of all, we know that there are many existing kilns available which could be retrofitted. And this we are supporting. This is the first statement. So if you have some idea on old, let's say, rotary kilns which are available, then we can talk about retrofitting, no problem. If it comes to new build plants, so greenfield plants, then we think that the flash activator should be the choice. For sure, this is depending on the raw clay, but in general, we see much advantages of the flash activation unit. So basically, we are also able to build rotary kilns, for sure, we are doing since years. But in this case, we really don't see an advantage of the rotary solution because we could show that the costs are nearly the same. So this is not a big differentiator at the end. And we see that the product quality of the flash activator is simply better. So we are saying typically we would like to go for a flash activator when speaking about greenfield plants. So with this flash activator, we are able to activate also mixed clay minerals. This is because we don't have the very large retention time as we have it in the rotary kiln. So the kinetics is quite fast in our system. We are activating the clay within seconds, so 1 or 2 seconds, and the clay is activated. Compared to a rotary kiln, this would take much longer. So we are there in the range of minutes. So this is giving a, let's say, quite flexible system at the end, and good to control system. For sure, we have to prepare our clay here for our process to make the clay flyable. So for this, we are using a hammer de-agglomerator. But this is nevertheless needed. If you talk about color control, you cannot control the color of a clay which is quite coarse. So in any case, you have to bring the clay to a quite fine particle size to do color control. If you go for a flash or if you go for the rotary kiln, that doesn't care. So also this cannot be seen as a disadvantage in our system. So another thing is here, and this is, I think, one of the most important, the precise temperature steering. So I just told you that it is very needed to have the right temperature window for activation. We don't want to overheat the material. This would lead to a bad product quality. And the temperature for activation, we can steer very good in the flash activator. So let me come here to the Opex advantages. For sure, we are having quite low heat consumption because we are recuperating the heat within the system using cyclone stages, for example, for preheating, but also for post-cooling. We are able to implement alternative fuel incineration here. So if you have alternative fuels, this is also possible with this system. It is a very flexible system, so you can also go to coarse alternative fuel, not just very fine alternative fuel, which is quite expensive, but also the very cheap, low quality alternative fuel you can use. And as you don't have any or that much rotating equipment here, the maintenance is also quite low in Opex. So at the end, and this is my message here, the product quality of the system is driving our solution, and in combination with an equal capex, let's say, invest cost to rotary kiln, we are suggesting to our customers in most cases to go for this kind of activation unit when it comes to greenfield plants. Good. Now let's go a bit deeper into the process. So what are the typical steps? I mentioned several times that the color is of very high importance here. So depending on the clay you have, meaning depending on the iron oxide contents of the clay will become a reddish color after activation. And in the most markets, it is not wanted, let's say, from the end customer. The end customer would like to have a gray product. And this is what we can do. So we are testing the material in the lab. We are finding out if there is a color change or not. And if there's a color change, we will apply a special process to bring the color from reddish to gray. When starting now with the raw clay preparation, we are typically sieving the clay. We are having, in some cases, a partial homogenization. So this is depending on the clay deposit at the end. We are separating hard rocks if available or if contained, let's say. And then afterwards, we are feeding hammer deagglomerator with this clay. We are deagglomerating the clay to below 2 millimeters. Afterwards, we are feeding our preheater system, and then we are giving it into the activator unit. I will show you a flow sheet on the next slide. So the last point then is the cement production. So here there are principally two ways. One way would be to have an intergrinding together with clinker, limestone, gypsum. And the other way would be to have a separate grinding. So just grind activated clay and then afterwards mix it with the cement. And this might be of advantage later because you are pretty well able to steer the quality of the cement when applying a separate grinding. So this is what we're working currently on. We are also having a special mill for this, which is called a booster mill. So this is basically an agitated bead mill. And this we are applying for that. Okay, just to give you a rough overview of the process, I will show you this basic flow sheet here for the oxidizing process. So what we are doing, let's start on the left-hand side here. We are taking the raw clay and we are feeding the hammer deagglomerator with this material. Additionally, we are also putting in some waste heat into our system for drying. So we are not just deagglomerating, but we are also drying the material in the hammer mill, as well as in the attached flash dryer. So we are bringing down the moisture here to below 2%. And directly attached, we are bringing then the material to the preheater, where the material is then preheated to a temperature of around 500 or 600 degrees C before entering the activator unit. So the activation is then done in this activator unit at the certain temperature between, let's say, 800, 900 degrees C, depending on the clay. And then the material stream is separated in the product cyclone. Afterwards, the material stream is guided into post-coolers to recuperate the heat from the material and to reuse the heat in the system. So this is making, bringing the Opex quite low here. Afterwards, we are also having a post-cooling step to bring the temperature down to 80 or 100 degrees C. And also this waste heat here can be used either for the drying here or maybe also for some other purposes. At the end, you are coming up with the activated clay, which can then be grinded. So one opportunity would be the intergrinding, meaning you are grinding the activated clay together with clinker, limestone, gypsum. This is possible. Or if you don't want to do like this, You can also have a separate grinding step, so just grinding the activated clay itself, and then afterwards feeding, for example, let's say mixing to the final cement. This is also possible. So this is one example for a typical hammer mill and flash dryer application. As I told you before, we are sieving the material. So we are just putting material with the size of around 50 millimeters here in the hammer mill. There's also the use of waste heat is also possible here, or let's say heat from the cooling section we can also use here. We are de-agglomerating the clay in the hammer mill, and then we are drying it in the attached flash dryer. So in this case, there's also a static separator to put out some hard rocks. So this is not needed in all cases, but in this case it is needed. We are bringing down the moisture to below 2%, and we are afterwards feeding the product into the preheater activator unit. So there's no separate transport needed because we're transporting the material with the airstream to the top of the tower. Okay, so afterwards, as I said, we are feeding our preheater system, which is typically 2 preheating cyclones, depending. And afterwards, we are feeding our clay activator, where the clay is then activated between 700 and 900 degrees C. We are able to recuperate the heat from the coolers, and we are, as I said, preheating the clay due to product quality reasons. Okay, then I would like to show you our first reference, which is currently built in Africa. So what you see here is a 720 tons per day plant, which is built in West Africa. We could place a clinker storage here, so the customer is importing clinker from overseas. We are also applying raw clay storages here, as well as a hard rock separator to put out the granite pieces of this material. Then we are activating the clay in our, let's say, a flash activation unit, which you can see here in the middle. This unit is coal-fired and also including color control. Then afterwards, we are storing the activated clay in 2 silos, and we are feeding the clay together with clinker gypsum to the ball mill, which is the intergrinding device. This customer is able to produce several types of cement, and then afterwards, he will store the cements in these silos here. So this is the world's first greenfield EPC flash activation unit, which is then built by TKIS Polysius. The commissioning will be end of next year, and we are really looking forward to, let's say, commission this plant. What I also have to add here is that everything started with the geo and lab services, as I showed you before. So this is really, if we talk about clays, it is really needed to have a detailed look on the clay source itself, because everything is depending on the clay you are using. The whole layout, we have to change some things here. It's all depending on the clay input. And this is why we are putting so much efforts also in the geo and lab services, because we know that this is the first step, which is the most important. Okay, let me come to the business case for Indonesia. So first of all, let's have a look on the first part here, number 1. So according to our market insights, this here should be a typical composition of cement for Indonesian market. What you see here is, first of all, an OPC with 15% of the portfolio, and then a PPC with 85% of the portfolio. The numbers here are coming, let's say, from the market in Indonesia. So the OPC is containing around 90% clinker, 8% limestone, 4% gypsum in this case. This can vary from case to case for sure, but this is the basis, let's say, for this calculation. And then we have the PPC, which is containing 70% clinker, 17% limestone, and 3% gypsum, as well as 10% other pozzolanic material. So this is our base case we just used for this evaluation here. We also received some costs for clinker, limestone, so electricity, fuel costs, etc. And we did the first business case evaluation on this. So this is the today's cement portfolio. And then we built up two scenarios. So the second scenario is to substitute the PPC by PPC substitute, which is then activated clay cement. So here we can use, let's say, very low clinker content of around 40 to 50%. We can apply limestone content between 10 and 20%. And we can implement activated clay of around 30 to 40%. So just to give you a number here. And with this composition, you will come up with a quite good quality. So this is at least the same quality like PPC, maybe better. And the overall costs for production will then decrease by around 3 to 4 euros per ton. So just by, let's say, reducing the clinker factor here, this is a very, very huge lever for sure, but also to add some activated clay, which is contributing to the strength development. So this is not inert. Activated clay is really actively giving some strength, input to strength development. So this is if you just, let's say, replace the PPC by an activated clay cement. If you are also going the way and saying, okay, I can also substitute my OPC using the LC350, this you can also do. And in this case, this would then be the best case. You will then come up with costs which are between 16, 17 euros per ton. So again, this is just based on the input we have at the moment from the market. I think the costs will vary from customer to customer. And for this reason, I'm just saying on the next slide, or suggesting on the next slide to also run a business case for your case. But first of all, let me sum up here. So when applying, let's say, this activated clay cement in Indonesia, we see a potential which is only due to clinker factor reduction. And this potential is somewhere between 5 to 9 million euros per year for a 5,000 tons per day cement production. Just a rough figure to give you an impression. If there should be the case that you are also willing to increase your cement capacity, this is for sure possible, then this number will further increase. But this is, according to our knowledge in Indonesia, not often the case, let's say. We think that the case in Indonesia is more to reduce the clinker factor. And this is why I just pointed out here the clinker factor reduction, first of all. So this is the range we are talking about. And for sure, as I said before, this is depending from the individual costs of the plant and of the customer. And for this, we are suggesting you today to get your own business case. And for this, I would just ask you to contact my colleague Ridwan from Indonesia. He will support you there. He will send you the input data sheet, which we have prepared. You will have to share your input data with us. And then afterwards, we will internally run your business case, and we will show you what's the potential for you individually to apply activated clay in your cement portfolio. So this will be our offer to you today. And if you are interested, please directly contact Ridwan. Okay, with this, I would like to end my presentation. So thank you very much for your attention. I hope you enjoyed the presentation. And if you have some questions, please contact Ridwan or directly me. This is no problem. And if you would like to also have a look on our other solutions, which are under the umbrella of our green cement plant, then please feel free to also visit our homepage. Thank you very much. And now I'm open for your questions.
Okay, thank you very much, Mr. Leo, for your very interesting presentation. For your detail, I think, and hopefully providing clear information about the activated clay to all participants. Now, time to the committee to collect questions from participants. While waiting to collect questions from participants, we will play a short video about the thyssenkrupp industrial solution. Okay, please play the video.
Satu, dua, tiga, empat.
Belum dibilang.
Okay, should we go on with the questions here?
Well, we have collect all questions from the participant, and there are many questions, and I hope you can, Mr. Leo, you can answer the question. For the question in Indonesia, Mr. Ridwan in Indonesia will help you to translate the question to English so you can answer the question correctly. Okay, time for you to answer the question from the participant, Leo.
Okay, all right, I will do it. Yes. So let's start with the first one here. So what percentage of activated clay can save limestone reserve as the main raw material for the cement manufacturing industry? So this is sure depending on what cement you are producing today. What I want to do in the case is that we can replace around 2% by activating. So for sure you can do but the limestone is quite. We there's an echo at the moment. Mike?
Hi, Leo. I think your sound is not so clear.
Okay, now maybe better. There's an echo. Look like that. 1 second, please. All right, so I guess. Right, so yes, this will also save some limestone, but this is not the main target. The main target is to save costs at the end. So to make your cement production as efficient as possible. And if the limestone is quite cheap in the region, then this is also indicating that it is available, let's say, and we are targeting more, let's say, on the product quality at the end, and not only replacing it. But yes, you will also save some limestone. Okay, then the next question is it needed to improve or replace our existing equipment in our cement plant when using activated clay? So in this case, I understand the question in such that if you are producing activated clay and you would like to grind it, if you need some new invest into grinding equipment. And this especially has to be answered according to your today's equipment sizing. So if there is some, if you just would like to replace clinker by activated clay, then it should be possible to use the same mill than before. So having an intergrinding. If we would like to go for a separate grinding, for sure you need to invest in a small mill. But in this case, we are currently thinking that we can go with a very efficient and small booster mill, Polysius booster mill, which is not that. So then there's the question on how many months for the invest and when to come to the break-even point for a 5,000 tons per day plant. So as I showed you here in the presentation, we're expecting savings of around 5 to 9 million euros per year. And this will then basically lead to an amortization time between, let's say, 3 to 5 years, something like that. This would be expected. But also this, I can just say that we should really do a detailed business case calculation for your individual case to really come to a final number here. So this is just an indication which I can show you here. Maybe it's faster, maybe it will take longer, but in general, we think maximum 5 years, because everything else is not, let's say, wanted at the end. So then there's the question on Belit cements, and what about the energy reduction if compared to calcined clay? So what I can say here is that for calcined clay production, we will need let's say energy of around between 5 and 600 kcal per kg. This is very depending on the moisture level. So also here, just a rough estimate. And if compared to standard cement clinker, this is around 35 to 40% less in energy consumption. This we can say. So how much we can reduce the production cost if we change pozzolanic material with activated clays? This is what I also showed you in the business case here. So I'm not only replacing pozzolanic material here, but I'm also replacing a bit of limestone. And especially we are also reducing the clinker, because the activity of activated clay is quite a good one. And this allows you not just to replace pozzolanic material, but also to reduce the clinker factor, which this is the main lever at the end. So, and then in this case, I showed you some figures of between 4 to 6 euros per ton price reduction, something like that in the range. But also here, please contact Ritwan for a detailed business case calculation. So then there's another question in line number 10. So please, someone, could you translate for me?
Okay, Leo, let me translate for the question number 10. So the question is there any difference in regard of the clay quality that's being used for the raw mill and the cement?
So in this case, we can also use clay which is available today. But in most cases, this quality which you use there in the cement plant is mostly a quite good quality. So this might be too expensive for activated clay production. We have to have a look on the prices. So if you say you have something available which is fitting to our demands, which I showed you in the presentation, meaning to chemistry as well as to kaolinite content at low prices, then we can use the same one, yes. But if this is too expensive as a raw material, then it doesn't make sense to use it. So also here, the business case would be needed to show if it makes sense to go for this raw material at a certain price, or maybe if it's for an alternative quarry here. Okay, then the next one is how many % activated clay can CO2 reduction? So I think you would like to know the amount of CO2 reduction potential. So when comparing to OPC and then going to this LC350, we speak about around 40% CO2 reduction. If today there's also used some limestone in the mix, which is the case in Indonesia, as well as some other pozzolanic material, then compared to this composition of PPC, it will not be 40%, but it will be lower, something like maybe 20 or something. But compared to OPC, you will save around 40% when using SC3 cement. So the second one, which cement factory used activated clay in Indonesia? So there maybe my colleague has some more insights. So I don't know if there is one at the moment.
At the moment, we don't have.
Can you say something about this question?
Yes, yes.
There is a cement factory today which is using activated clay.
Yes, can you hear my sound? Hello, Leo. Hello. Hello.
Okay, so Ritwan is not available, obviously. So then I will just go ahead here. Can you please scroll down
Hello, Leo.
So that I can read the question number 14 and the others.
Hello, Leo. Leo.
Okay. So this one I can also read. Okay. Can you hear
Hello,
me?
Leo. Can you hear
Is there a
me?
connection problem?
Leo?
Leo, can you hear me?
Okay, now. Okay, thank you. So how do we add calcined clay in our process? Do we just add it into the finish mill before or after? If after, so clay particle size must be the same as the cement particle size to make them blend together. Okay, so there are several options here. First option would be to put it together with clinker in one mill, for example, a ball mill, and then to grind it, have an intergrinding. So the disadvantage here is that you cannot steer the quality, let's say the fineness of the activated clay in relation to the fineness of the clinker very, very good. So you can just put it in and then, let's say, adapt it a bit and optimize a bit, but you are not able to really steer the quality in a very good way. So you can do, and this is also done in the market, no problem. But another opportunity would be to really have the cement grinding, meaning clinker grinding, etc., separated from the activated clay grinding. And then in this case, you can adjust the particle sizes, for example, the residue, for example, or the blane value of the activated clay accordingly, because you are having a separate mill. And then you can feed the separator, for example, with this activated clay. And you don't need the same particle size distribution. No, you can adjust the particle size distribution of the activated clay so that at the end, you will come up with the best product quality. It doesn't need to be the same, but it has to be mixed then afterwards. So the next one. Yeah, so this is, I think, something I just tried to answer here in the question before. So the question is the pros and cons of co-grinding and separate grinding. So especially strength development, workability, durability. So what we can say here is that activated clay is, let's say, quite fine material. So there's a of activated clay. You easily reach blane values of 5, 6, 7, 8,000 blanes, which is very, very high surface and basically leading to a high water demand. So what we need to do is to just bring the activated clay to the fineness which is really needed for your quality demand. So this is also one reason why separate grinding would be a good choice to really steer the quality of the final cement. So also we think, or we know you can also adapt the workability and the water demand with separate grinding in a very good way. This is what we're investigating at the moment with the so-called Polysius booster mill in our lab in Germany. So we are investigating the effect of separate grinding on the strength development, workability, water demand, etc. This is what's currently done, and the results will be available in some weeks. Okay, so in this case here, the question number 17 is again according to some changes which are needed. And yeah, so for sure you will need a clay activation line, this is clear. And then, as I said, it depends. It depends what is your current equipment. Do we have a mill available which has some capacity? Should we go for separate or intergrinding? So all these questions we have to answer on project level here. to really find the right answer. But in general, maybe there might be some changes in the cement production itself. So there will be some changes at the end, but then it should be, yeah, more or less it at the end. Maybe a silo, we have to look on your silos if you have some silos available. Yeah, but this we can manage, no problem. So now I'm reading the question number 18. Yes, so here you are asking for a feasibility study to calculate the budget on clay activated project. So, okay, compare with using fly ash filler project to cement blending making. Okay, so if I get this question right, oh, 1 second, I cannot read it anymore. Then this is about a comparison between using fly ashes as well as using activated clay. So for sure, if you use fly ash, which is available, this fly ash is quite cheap. So we have to compete against fly ash with activated clay production. This is depending on the cost for fly ash and also depending on the needed quality. So we think that we can substitute more clinker when using activated clay than using fly ash because the activated clay has a higher activity. So in this case, we have to compare which amount of clinker can be saved when going to activated clay. And we have to put in the cost for the fly ash today, as well as the production cost for the activated clay. And with this, we can build up a feasibility study. This is no problem, just contact Ridwan. And we can also then share some costs here. Okay, if you just go to the next question, please. Number 19.
Tolong diputar ke atas.
Okay, there it is. If we compare activated clay with PCC, I cannot read the question. PCC, which is better about strength cement? Yeah, this depends. So the target should be that we replace the PCC, which is today in your portfolio, by activated clay cement. This is the target. And we would like to substitute as much as clinker as possible to come to the same quality of the cement. This is the target. And this is what I just wanted to show you in the business case also. So we think we can reduce the clinker content to 40 or 50%. And at the same time, achieving the same quality like you have today with the PCC. This would be the target, but we have to investigate if this is possible. So in this case, we would have the same strength, so same quality, but lower cost. And this is what is making it quite attractive. Okay, so the cost question, yeah, I can just say that what I said before. So the typical amortization time for this business case here will be something between 3 to 5 years. This is what can be expected. So then, next question. Okay, so here's the question on if the reducing of the clinker factor is having an effect on the compressive strength of cement. So yes, for sure, this is the case normally. if you just talk about using standard fillers like limestone, then a reduced clinker content will lead to drastically decreased compressive strength. That's absolutely correct. If we talk about activated clay, you all know that this is an active component. So this is reacting with limestone and clinker together. And this is giving some strength advantages. And this is the reason why we can say that these 50%, for example, of clinker are leading to the same final strength compared to OPC. So there's no negative impact on compressive strength. For sure, if you reduce the clinker content further and further, then there's some point where the compressive strength is not sufficient anymore. But this we are finding out for you, for your case in the lab. And we are telling you, okay, you can decrease the clinker factor to a certain amount after checking the clay and after checking the clinker. So what is the differences, physical differences between normal dried clay and activated clay? Yeah, the difference is that when talking about standard clay, there's typically a quite high amount of clay minerals in it, which is not active. So what I wanted to show you on my slide 11 is that in the raw clay, there is a certain raw, let's say, kaolinite content, which is not active in the raw clay. So it is not contributing to the strength development. We want to make the kaoline active, and this is why we are activating it. So in this case, the difference is that in the raw clay, there's not that much active material as in the activated material. So at the end, you are able to replace more clinker with activated clay compared to raw clay. Okay, so what's the next question? What is pros and cons cement produced by co-grinding compared to blended activated clay with Portland cement, especially in strength development? And I think this question was placed before. So next one. 1 second. Yeah. So what is the invest cost to build a new activated clay plant with capacity 1,000? How much is it? 1 million? 100,000? 100,000 tons per year. Let me just check the number. Oh, it's a quite small one, right? 300 tons per day. Typically something like that where, let's say, nobody asked for because it's too small. So I cannot give a price indication for that. Let's say standard, if you talk about 1,000 tons per day or maybe 900, 800, this would be in the range of EPC, something between 20 to 30 million, just to give you a rough estimate. But also this one here is then quite depending on the clay properties, on the fuel you are using, on the reducing process or oxidizing process. So also this one, just very rough. We need to know what clay we are talking about, what's the moisture to really give a precise cost estimate here. Why the color of product is very important. What is color point of product? Yeah, so from a quality point of view, the color does not impact the quality at the end. So this is just because the cement industry is quite conservative, because the end customer is willing to buy a gray cement instead of a reddish cement. This is the only reason. But also here again, not all raw clays are turning their color into red. There are also clays available with a low iron content, which will not change their color. So also this is possible. But yes, the color is only important due to marketing reasons. It's not affecting the product quality. Yeah, so this question was also answered, number 26. We're currently working on investigating the separate mixing or separate grinding, let's say, and mixing. We think that there might be advantages if you do it separately, because you are able to steer the quality or the properties of the activated clay independently from the properties of the clinker and other ingredients. So this is the reason why we're thinking that a separate grinding could make sense. But as I said, the final results will come in some weeks. Okay, then there's the question on the chemical parameters. LOI, why must it be higher than 7%? So at the end, this value here is giving us only the indication if there is, let's say, some clay in it or not. And if we are talking about kaolinitic clays, there must be a certain minimum of kaolinite within the clay. And this LOI of around 7% is indicating that there is a clay in this, that there is a mineral in this clay, especially a kaolinite, which is then contributing at the end to the strength development. So this LOI is just giving us the indication that there is a suitable clay in it. But again, this is just the first estimate. In all cases, we have to also go for a mineral analysis. And latest in this stage of the mineral analysis, we will then see which clay minerals are in and which are not in. So then a question concerning the setting time of cement. So this is within the typical range, first of all. Here, a special question I have to speak about with my head of lab in Germany. How is the compatibility of activated clay with the chemical cement additive? So what do we exactly mean with this question number 3?
Maybe Leo, if there is no clear, maybe
I think we have to clarify that.
Yes, we have clarified first, and then we can send.
The question here from my side would be, what kind of chemical cement additives are you speaking about here?
Leo, can you hear me?
Okay, this we can then check later on. How much average production cost of activated clay per ton? Yes, so also this is coming out of the business case. So I showed you here for Indonesia market, at least I can tell you the average production cost of this mix, which is around 16 euros. And for the clay, it will be even lower, of course. This figure I have to look up. So then there's question 29. Please translate, Ritwan.
Hello, Leo. Leo?
Yes. Okay, yes, now I can hear you.
Okay. So the question number 29. For the material that have the alumina content below 18%, can be used for the activated clay or not?
Okay, so then it's important where this figure is. So is it 16, 17, then maybe we can use it. Is it below 13, 14, then I think we cannot use it. It depends. So if you just are directly near to this value, we can talk about it. And otherwise we will have to do an investigation in the lab to have a look on the clay minerals and then to give you an indication.
And then what is the lowest range of the alumina content that's being used for the activated clay?
Yeah, typical range is something around 16, 17, 18, something like that. So most of our samples are fulfilling these criteria here. But as I said, we can have a detailed look on this material. So if you say this is my preferred quarry, you can just have a rough view on the chemistry as well as on the mineral composition. So it's not that expensive and then to give you an indication. If this is important for you to maybe use another type of clay, we should have a look on it before saying that this is possible or not possible to be used. All right, question 30. Ridwan, could you please translate?
So for the question 30, for the use of the activated clay, is there any follow the standard regulation for the SNI? SNI is the standard national Indonesia, and maybe you are not common with this standard. Maybe you can use as the ASTM, for example.
So according to ASTM, for sure, there are some boundary conditions, but we can see that this is the type IT, so ternary blend for LC3. And according to ASTM, you can use this LC350 cements if you fulfill a certain index here. But in most cases, it is possible. Yeah. So you have to do some strength tests, and you have to show the SAI index, let's say, so compared to standard cement, and then basically you are allowed to use this kind of cement. Yes.
Maybe there is a question. Tadi ada pertanyaan mengenai reference. Tadi mungkin ada kesalahan teknis mengenai reference activated clay di Indonesia. At the moment belum ada, Pak. Jadi sementara ini reference-nya itu ada di Eropa dan Afrika. Mungkin nanti kita akan provide juga reference list untuk activated clay teknologi kami. Terima kasih, Pak.
Okay, thank you very much for your answering almost all the questions from the participant. And although the question from the participant have been answered orally, I think it will be better if you also answer the question in writing, so all participants can read your answer in other time. Is it okay, Mr. Leo?
Yes, sure. Send me the questions and we will answer them.
Okay. We will send all the questions from participant to you, and please answer it and in writing, and then send back to us again to us, and we will distribute to all participants.
Okay, good.
Okay. I think time is up, and once again we thank you for this very interesting presentation, and we hope that we can still work together in the future.
Okay, thank you for listening.
Okay, thank you once again. Dan kita akan lanjutkan. Ada sedikit satu pertanyaan tadi yang spesifik untuk Pak Widodo Santoso terkait dengan kapan penjualan semen akan balik normal. Apakah Pak Widodo masih bergabung dengan kita, Pak Widodo? Halo, Pak Widodo. Menurut data, Pak Widodo masih terhubung dengan kita, tetapi mungkin beliau sudah ada kesibukan. Saya coba lagi, Pak Widodo, apakah masih bergabung, Pak? Baik, kayaknya Pak Widodo sedang tidak aktif berhubungan dengan kita. Tapi jangan khawatir, pertanyaan yang tadi belum sempat terjawab atau pertanyaan yang sudah terjawab sekalipun akan kita ulang juga dalam jawaban dalam tulisan dan itu akan kita kirimkan ke semua peserta lewat email dan atau WA. Jadi jangan khawatir untuk Bapak Ibu yang mungkin pertanyaannya belum sempat terjawab, tapi akan kita jawab tertulis nantinya dan akan kita kirimkan via email oleh panitia. Melanjutkan ke acara berikutnya, untuk kepentingan pembuatan e-sertifikat, panitia sudah atau belum ya, akan segera mengirimkan link daftar hadir, dan mohon peserta yang masih mengikuti webinar ini untuk mengisi daftar hadir ini untuk kepentingan pembuatan e-sertifikat. Sambil menunggu pengisian daftar hadir ini, panitia akan memutarkan video terkait thyssenkrupp. Silakan.
Sudah siap ya? Waduh, mana sih? Enggak. Habis ini aja ya. Ambil makasih selamat atas perhatiannya. Kita tunggu webinar kelima gitu kan? Nah, ada promosi gitu ya. Pada kira-kira akhir bulan Januari gitu ya.
Halo Pak Widodo.
Ya, oke.
Oh, masih nih ya Pak. Tadi ada satu pertanyaan terkait dengan... Halo Pak Widodo.
Iya.
Tadi ada satu pertanyaan terkait dengan presentasinya Pak, atau sambutan Pak Widodo tadi. Barangkali Pak Widodo bisa jawab.
Iya, oke. Ya, jadi ada 2 pertanyaan tadi ya, masalah Clinker sama masalah kapan nih ya. Dari teman-teman sekalian, tadi sudah sampaikan bahwa tahun depan itu 8% ya. Jadi memang kan kita lihat ini vaksin sudah datang. Saya yakin semester 2 sudah tidak ada lagi ya gejala corona yang terkait dengan hambatan ekonomi. Nah, itu yang pertama. Makanya semester 2 pasti lebih besar daripada sekarang. Yang kedua, infrastruktur itu dinaikkan di pemerintah. Tahun lalu PUPR ya itu hanya dikasih 75 triliun. Nanti kita dinaikkan ke 135 triliun. Itu pasti semuanya akan naik ya. Infrastruktur akan naik. Nah, yang ketiga ini informasi dari pemerintah. Semester 2 itu sudah mulai itu pembangunan ibu kota baru. Nah, itulah kira-kira pada semester 1 memang more or less seperti tahun lalu. Tapi kira-kira mulai Mei sudah mulai menanjak ya. Nah, itu kira-kira kemudian semester 2 pasti gebrakan bagus. Makanya teman-teman siap-siap semester 2 tahun depan itu pasti lebih besar dari sekarang. Nah, itu kira-kira sehingga tadi saya prediksi itu kira-kira 8% lah naiknya. Tapi bukan berarti lebih besar daripada tahun 2019. Tahun 2019 kan kalau naik 10% baru sama dengan tahun 2019. Nah, itu kira-kira. Tapi karena ekspornya kira-kira naik 10 juta, nah, jadi nanti itu kira-kira ya more or less sama dengan tahun 2019 lah ya, permintaan semen. Itu kira-kira. Nah, itu kira-kira. Kemudian yang kedua adalah tanya tadi masalah Clinker yang baik gimana. Clinker kita itu Pak, jadi kita itu sudah terbagus loh di Asia. Kalau nggak bagus nggak akan kita bisa ekspor sekitar 9 juta. Jadi jangan merendahkan remehkan Clinker di dalam negeri. Itu sangat bagus kalau karena di Cina sudah diterima, Bangladesh diterima, di Afrika diterima. Jadi Clinker kita itu standarnya itu adalah liter weight-nya itu harus harus antara 1.200 ya, 1.200. Kemudian masalah apa? Masalah itu apa masalah liter weight, kemudian masalah C3S ya, C3S itu jangan harus sekitar 60%, itu sudah standar ya. Kemudian free lime-nya itu jangan lebih dari 1,2%, itu aja. Saya kira teman-teman sudah bisa membuat itu, dan makanya sekarang kan PCC sudah bagus ya. Teman-teman bisa Clinker faktornya sampai 75%. Sampai 65% juga bisa kalau Clinkernya bagus. Jadi masalah Clinker jangan remehkan, dalam bagi kita itu Clinkernya sudah startup internasional. Itu kira-kira Bapak sekalian yang bisa saya bantu mengenai pertanyaan tadi. Semoga merupakan masukannya bagus. Ke masalah gimana cost-nya supaya rendah membuat semen. Yaitu membuat blended semen. Blended semen itu apa? Ya semen yang Clinker faktornya bagus, yaitu Portland Pozola semen dan Portland Compressive semen. Itu sekarang yang kita galakkan, yang sudah istilahnya semen ramah lingkungan. Itu sudah dipakai di proyek-proyek, sehingga cost production kita bisa rendah. Itu Mas tambahan dari saya. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Terima kasih Pak Widodo atas jawabannya. Mudah-mudahan penanya puas dengan jawaban Pak Widodo, dan tahun depan pemikiran Pak Widodo bisa terlaksana betul sehingga kapasitas semen di Indonesia bisa terpakai dengan
ya. Jadi selama teman-teman mengikuti webinar kelima pada akhir Januari, mungkin topiknya akan lebih menarik lagi. Terima kasih.
Terima kasih Pak Widodo. Baik, itu tadi jawaban dari Pak Widodo terkait dengan pertanyaan yang berhubungan dengan sambutan yang oleh Pak Widodo tadi. Mudah-mudahan menjawab pertanyaan dari peserta. Baik, sekarang kita masuk ke pengumuman terhadap 5 peserta yang beruntung mendapatkan souvenir. Mudah-mudahan semua peserta sudah sempat mengisi daftar hadir dan pasti panitia sudah selesai mengkolek semua data sehingga bisa memutuskan 5 peserta yang beruntung mendapatkan souvenir. Dalam hal ini peserta yang beruntung adalah peserta yang menjawab atau menulis daftar hadir pertama, 5 yang pertama. Oke, saya masih menunggu dari panitia siapa saja yang berbahagia mendapatkan souvenir dari ISBI. Kita tunggu sebentar. Sedikit lagi untuk menetapkan 5 peserta yang beruntung mendapatkan. Baik, data sudah terkumpul. Yang pertama beruntung mendapatkan souvenir dari ISBI adalah, maaf, ini saya kurang jelas, mungkin Bapak kali ya, Bapak Andi Permana. Mudah-mudahan nggak salah, Bapak Andi Permana ya. dari PT Semindo Gemilang. Jadi Bapak Anggi Permana beruntung untuk yang pertama mendapatkan souvenir. Kemudian yang kedua, Bapak Yusuf Afandi. Bapak Yusuf Afandi dari PT Semen Gresik. Kemudian yang ketiga, Bapak Jeffrey Anthony dari PT Semen Padang. Oke. Yang keempat, yang beruntung adalah Bapak Yusran Agustin. Bapak Yusran Agustin dari PT Semen Padang lagi. Oh, ini PT Semen Padang kayaknya memang banyak yang ikut nih. Sampai 2 orang sekaligus mendapatkan souvenir. Yang terakhir adalah Bapak Muhammad Rizki. Bapak Muhammad Rizki dari, ini mahasiswa magang nih, mahasiswa magang. Maka ya udah bersyukur nih ada mahasiswa juga yang tertarik dengan webinar ini, mungkin sangat tertarik sehingga sekaligus mendapatkan souvenir dari ISBI. Jadi itu adalah 5 orang partisipan peserta webinar ini yang beruntung mendapatkan souvenir dari ISBI. Panitia akan segera mengirimkan souvenir ini segera ke alamat email. Mohon Bapak-bapak, Ibu-ibu yang mendapatkan souvenir tadi mengirimkan alamat detail supaya panitia bisa mengirimkan souvenir ini ke alamat yang tepat dan dalam waktu yang tepat. Baik, itu adalah rangkaian webinar kita kali ini. Sebelum ditutup, kita akan foto bersama dulu. Oh, maaf. Ada yang terlepas satu. Ada pesan-kesan dari peserta webinar ini terkait dengan webinar keempat kita yang bersedia untuk memberikan kesan-pesan pada webinar kali ini adalah Bapak Mansur Shah Nasution. Selamat sore Pak Mansur. Sudah lama nggak bertemu nih.
Selamat sore. Mohon
bisa memberikan kesan-pesannya. Silakan waktu untuk Pak Mansur.
Baik, bisa dengar ya?
Kurang jelas sedikit Pak. Kurang keras Pak.
Oke, masuk ya. Bismillahirrahmanirrahim.
Maaf Pak, kurang keras sedikit Pak.
Oke. Selamat sore. Bisa udah?
Sore Pak. Sore.
Ya.
Silakan.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Baik, Bapak-bapak sekalian dan Ibu yang saya hormati, sesuai dengan permintaan panitia untuk menyampaikan kesan-kesan. Namun sebelumnya saya mohon izin dulu ke seluruh peserta yang ada sore ini bahwa apa yang saya sampaikan mudah-mudahan bisa mewakili dari suara kita semua. Ya. Yang pertama, dalam webinar 4 ini saya mewakili peserta menyampaikan apresiasi yang tinggi kepada ISBI yang telah mempunyai prakarsa dalam melaksanakan seminar ini, sehingga ini seminar yang cukup informatif bagi kita dan sangat kita butuhkan di industri semen ini. Bagi kita sebagai pelaku-pelaku industri semen ini, apakah sebagai mahasiswa, sebagai engineer, kemudian sebagai dosen, ini informasi-informasi yang sangat dibutuhkan bagi kita. Apalagi ini ada satu teknologi pengembangan yang baru yang membuat pikiran kita jadi terbuka lagi, sehingga material-material yang selama ini yang kita abaikan ternyata masih bisa dimanfaatkan. Nah, dengan teknologi, dengan prakarsa thyssenkrupp, ini bisa kita manfaatkan sehingga dalam industri semen juga kita akan lebih baik, dapat juga mengurangi emisi udara, dan inilah yang sangat kita butuhkan sebetulnya. Ke depan itu sebetulnya hal-hal yang seperti ini yang kita harapkan, bahwa ada inovasi-inovasi baru sehingga kita bisa dapat meningkatkan efisiensi dalam produksi, kemudian dapat kita meningkatkan pemanfaatan material-material bahan-bahan yang kita punya, supaya jangan sampai nanti bahan-bahan kita itu habis, kemudian kita nggak ada lagi bahan baku. Dengan demikian, dengan adanya teknologi baru ini, umur daripada deposit kita akan bisa bertambah lama. Itu kesan-kesan saya sampaikan. Mudah-mudahan harapan saya ini webinar ini bisa terus berlanjut dan ini bisa memprakarsainya dan materi-materi yang lebih ke depan untuk pengembangan industri semen agar bisa lebih efisien dan kita bisa bersaing dengan industri semen di luar negeri. Saya kira demikian, Pak. Mudah-mudahan bisa memenuhi keinginan kita bersama. Wabillahi taufiq wal hidayah. Assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih banyak Pak Mansur atas kesan dan pesannya yang mendorong kita ISBI untuk selalu menyampaikan inovasi-inovasi, terutama di industri semen dan industri yang lain pada umumnya. Dan untuk itu kita pada tahun berikutnya atau tahun 2021 akan tetap melaksanakan webinar dengan topik-topik yang lain yang tentu berhubungan dengan inovasi-inovasi untuk meningkatkan efisiensi. Terima kasih sekali lagi Pak Mansur atas kesan dan pesannya. Baik, sebelum foto-foto, jadi sebetulnya ini berakhir sudah webinar kita hari ini. Kami panitia mengucapkan banyak terima kasih atas kesediaan Bapak Ibu sekalian mengikuti webinar ini di akhir. Berharap materi yang disampaikan bermanfaat bagi Bapak Ibu semua. Dan tidak lupa saya mengucapkan terima kasih sekali lagi untuk Pak Anton Sumardianto, Mr. Leofit yang saya lihat sudah keluar dari webinar ini, dan tidak lupa dengan Pak Ridwan dari Desember Indonesia. Terima kasih banyak atas supportnya, dan juga untuk semua panitia terima kasih atas kerja kerasnya sehingga webinar kita bisa berjalan dengan baik. Mohon maaf atas kekurangan yang terjadi selama webinar ini. Tentu kita mengharapkan saran dan kritik dari Bapak Ibu peserta webinar ini untuk perbaikan webinar ISBI berikutnya. Sebelum kita tutup, seperti sudah saya sampaikan tadi, kita akan foto bersama. Silakan di-on-kan, diaktifkan videonya supaya panitia bisa mengambil foto Bapak Ibu semuanya untuk ya dokumentasi. Jadi nanti Bapak Ibu bisa melihat siapa saja yang ikut webinar ini, sudah saling kenal, bisa saling menyapa untuk berikutnya. Baik, silakan Pak Eko untuk melakukan membantu foto. Ayo, lompat kok. Buat.
Oke, Pak Arif, sudah Pak.
Baik, sudah semua ya? Baik, jadi sesi foto bersama sudah berlangsung, sudah selesai. Sekali lagi, webinar ini berakhir sampai di sini. Jangan lupa kami mohon ada masukan-masukan dari peserta untuk perbaikan webinar kita berikutnya. Sekali lagi, terima kasih atas partisipasinya. Sampai jumpa di webinar kelima ISBI tahun depan. Assalamualaikum warahmatullahi wabarakatuh.